All right, time to do some practice involving rules of differentiation. And you really want to practice. So go and try to do this with as many functions as you can that you have the rules for right now. Make this second nature. If you can make this process so natural to you that you do it without even thinking, a lot of the rest of calculus is going to be fun and enjoyable. And if you can't get there, it may not be as fun. It'll be fun. Of course it is. It's calculus. Come on. But not as fun. All right. So remember, as always, do as much of these problems as you can on your own. And if you're watching the solutions and working along, make frequent use of the pause button. The more that you can do by yourself, the better that you can do. All right. Let's get going. Our first problem. It's going to be a true-false question. Oh, I love these. 50-50 chance. Okay. Suppose our functions are f of x is x squared and g of x is x minus 2 to the minus 2. Okay. Is it the case that if I take the derivative, see that prime there? That's another symbol for the derivative. So here, this is just a shorthand. When you see this, this is saying, hey, take the derivative of f of x times g of x. And what is it saying? It's saying, oh, on this other side, it's the derivative of f of x times the derivative of g of x. Well, what do we know? We know that's not how the product rule works. Okay, so this was an easy problem. It's got to be false. All right, good. Cool, that was quick. Well, you know what? Just for sanity's sake, let's just go ahead and do the process and convince ourselves that indeed this is not how the product rule works. All right, so we begin. Well, what do we need to do? Well, let's work through and do these derivatives. Now, some of these derivatives are pretty straightforward. So, for instance, let's start with the derivative of f of x. So, f of x is x squared. All right, so f prime of x, that would be 2x, because derivative of x squared is 2x. That's the second nature. That should almost be like, without even thinking, you're like, oh yeah, derivative of x squared, 2x. Yeah, of course it is. All right, now let's start with g of x. This one's going to be a little bit more interesting. Notice that there's a negative exponent here. So let's see, what do we have? G of x is x minus 2 to the minus 2. Now, what's another way to write that? That is 1 over x minus 2 quantity squared. All right, that's true. True story. Okay, cool. By the way, x minus 2 squared, we can actually square that. So that's x squared minus 4x plus 4. All right, now, what can we do? So what rule would work for the derivative of g of x? Now, at this stage, we don't know how to handle x minus 2 on the inside. If it had only been x minus 2, it would be pretty straightforward. But the fact that there's a x minus 2 to the minus 2, we're not quite ready. We're not there. We will be. I tell you, we're going to be able to do a rule in the near future, and you can really say it's going to be a big game changer. All right, but let's pretend we don't know that rule. So we can still figure this out. So here's what we can do. Let's think about it in this way, and we're going to say, let's pull out the reciprocal rule. So g prime of x, the reciprocal rule says, what? Take the derivative of the denominator. Oh, don't forget there's a minus sign, by the way, with the reciprocal. Minus the derivative of the denominator. Well, let's use this. Let's take the derivative of that. That's their denominator. So that would be 2x minus 4. Then downstairs, what do we get? Be x minus 2 squared, because you square the denominator. Now, on a side note, let's actually make a cute little observation here. So if I pull the 2 out, what do we get? So minus 2, and then it would be x minus 2. Downstairs it would be x minus 2 to the 4th, because squared to the 4th. You multiply the powers. So now you subtract the powers, minus 2x minus 2 to the minus 3. Okay, so in essence what happened? It's like we brought the minus 2 down and to the minus 3. Kind of that's what we would expect to happen. Because if you're thinking about what the x minus 2 is doing, what is the minus 2 doing? The minus 2 is causing it to do a horizontal shifting left and right. And so you'd say, well, look, if I have a line here and I do a horizontal shift, the line, it's still the same line, just shifted over. So the slope is the same, just shifted. So we would kind of expect it to be the case. Okay, that's interesting. I wonder, whatever this rule is that I'm so excited about, but I'm not willing to say the name out loud. Yeah, it must be a great rule. Okay, well anyways, all right, now, we're almost there. Okay, so let's check. So first off, let's find what is f prime of x times g prime of x. That would be, if I take 2x times this expression, so 2x times that, all right, that has minus 4x, x minus 2 to negative 3. Okay, now, f of x, g of x. Now, we can actually take this derivative much the same way as we did here. In fact, we can use the quotient rule, right? So what do we have? Because f of x is x squared, that's x minus 2 to the minus 2. So we could say that if we're taking the derivative of f of x, g of x, so that's like the derivative of x squared over x minus 2 squared. And remember that x minus 2 squared has this other form. So what do? We're going to take the bottom, x minus 2 squared, times root of the top, which is 2x, minus the top, which is x squared, times the root of the bottom. Well, we actually did the root of the bottom. It's this thing right here. That 2 times x minus 2 is the root of the bottom. So times 2 times x minus 2 all over the bottom squared. Aha, see, they don't match. Like I said, it's going to be false. Okay, well, let's clean it up a little bit. What can we do? Well, they both have an x minus 2 in them, so let's go ahead and factor that out. And if we factor that out, what do we have here? Well, they both have a 2. So let's go ahead and factor that 2 out. So 2 and x minus 2. I missed an x minus 2 and I missed an x. So if I take x times x minus 2, that would be x squared minus 2x. Okay, and then here, what do we have? Well, here we got the 2, we got the x minus 2, so we didn't get the minus x squared. So minus x squared. Okay, so the x squared minus 2x is what was missing from the first piece, the minus x squared from the second piece. All that, of course, divided by, I forgot. The square my denominator. I'm so sorry. I did the quotient rule wrong. Did you see that? I need to square what's down here. So squared. Okay. So that's x minus 2 to the 4th. All right. Yeah, check your work. Now, hey, this is nice. Do you see that? The x squareds cancel. So let's see. What do we have here? We've got 2 times minus 2x, which is minus 4x. There's an x minus 2. And here there's an x minus 2 to the 4th. We can put those together by subtracting the exponents. So that's x minus 2 to the minus 3. And okay, so there's our derivative. Now, what do you notice? Uh-oh. They're the same. What? This is true. What? Okay, so let's pause for a second and sort of like catch our breath. Like, what's going on here? Okay, so what we've seen is a beautiful example of something that we call a coincidence. Now, you may have encountered a coincidence out in the wild. They happen all over the place. And some of the things that happen are, by coincidence, my sequence of crazy ideas produce the right answers. And therefore, my crazy ideas aren't so crazy. Now, sometimes that's a true statement. Sometimes your crazy ideas aren't so crazy, but sometimes they are, and you got a coincidence. And so you got to be really, really careful. So here's the case. It is 100% the case that as a general statement, the derivative of f times g is not the derivative of f times the derivative of g. That is a statement which is true in the sense that most of the time it is an absolute true statement. There are these rare exceptions or coincidences. What you have to do is you have to be careful. Just because you see a coincidence does not mean that because one case is true, it's true in general. That's why mathematicians go out of their way, and I think this is a good axiom to live by. Just because you see, oh, it's true in one case, does not mean it's going to be true in every case. So be careful not to overgeneralize things. There's probably a useful life lesson somewhere in here. Just because something happened once doesn't mean it's always going to happen. So, yeah. All right, good. Well, that was a little bit unexpected, but, good to learn. Good to learn. All right, on to the next problem. So, here we have the derivative of f of x times g of x times h of x, and we're going to take its derivative, and we're going to say, well, what is it in terms of f, g, h, f prime, g prime, h prime? So it's like a product rule, but instead of 2, we're going for 3. It's a triple product rule. Okay, so what are we going to do? Now, one thing you might be like, oh my gosh, we're going to have to go through and do the limits, and no, we're not going to do that. What we're going to do is we're going to build off the rules that we already have. It's a lot better to build off of what you already know to be true than to keep reinventing things and going back to basics. So it's like we're building up, We don't want to always keep going back to the very bottom to start over. It's like, hey, we have new tools. Let's use our new tools to see what we can do. Now, because we see it's a product rule, we say, hey, let's use the rules that we have. Let's use the product rule. Now, why might the product rule not work? Well, the product rule is designed to really help us when we have a product of 2 things. Here we have 3 things. Okay, so what do? Well, we say, let's make our 3 things look like 2 things. So here's our basic idea. We're going to say, hey, I'm going to take this product of 3 things, and I'm really going to think of it in the following sense. I'm going to take and group 2 of them together. Doesn't matter which 2. So let's say I'm going to group those 2 together. So now it's like, aha, I have one piece which is called f times g and another piece which is called h. So I can apply the product rule because now I have my 2 parts. So the product rule says take the derivative of the first, so the derivative of f of x times g of x, times the second, plus the first, f of x times g of x, times the derivative of the second. And the derivative of the second is h prime of x. I'm not done yet. I still have to have a derivative involved. But now it's like, oh, it's another product rule. So product rule says take the derivative of the first, f prime of x times g of x, plus the first times the derivative of the second, g prime of x. There we go. And there's an h of x, plus there's an f of x, g of x, times h prime of x. Now we'll distribute through. So in other words, the h of x comes through. So we get f prime of x, g of x, h of x, plus f of x, g prime of x, h of x, plus f of x, g of x, h prime of x. And now, if you take a look, you can see there's kind of this really cool pattern going here. And so what do you have? Well, there's 3 terms. In the first term, it's the f prime. In the second term, it's the g prime. And in the last term, the third term, is the h prime. So what happens is every single function gets to have a derivative taken, but we do it turn by turn. So it's like, you get a derivative, you get a derivative, every piece gets a derivative. Then you just have to take a turn. It's f gets the first turn, g gets the second, h gets the third, and you just work your way through until everybody's had a chance. And that's the same philosophy, by the way, that works with any number of terms multiplied together. Now, when you start to have lots and lots of terms multiplied together, there is actually a beautiful technique that we're going to learn about but it's a couple sessions down the road. But there's a way to handle lots and lots of multiplication. It's a great story. Keep going. Keep going. All right. Let's do another problem. All right. Let's do the following. Given that y equals 3x minus 7 is tangent to y equals f of x at x equals 2, find the tangent line to y equals x times f of x at x equals 2. Okay, so, we got to start sort of decoding what's going on here. Now, one of our basic philosophies, we mentioned it before, we'll mention it many times, is sort of the following idea. Is it says, hey, if I have a tangent line, so in other words, here's a little piece of information. So tangent line at x equals a, then really what I'm being told is, hey, I can tell you about the following two little pieces of data. What is f of a and f prime of a? And I can go back and forth between that. So we're told the tangent line, 3x minus 7, tangent to f of x at 2. So we can now extract the following two pieces of information. What is f of 2 and what is f prime of 2? So how do we get f of 2? Well, since the line is tangent, then the value of the function, the value of the line at 2 is the same as the value of the function at 2. So plug in 2. 2 times 3 is 6. 6 minus 7 is negative 1. And how do I get f prime of 2? Well, f prime of 2, that's the slope of the tangent line. It's the rate of change. So the slope of this line is 3. And there we go, negative 1 and 3. All right. Well, good. Now, that's what we know about f. So secretly, this tangent line information is, they've given us, hey, here's what f is at 2, f of 2 and f prime of 2. Now, how do we use it? Well, we're after a tangent line to something new. We're after the tangent line to x times f of x. So what we can do is we can say, let's think of x times f of x. This part right here, we can think of this as a new function. I'll call it g of x. So I want to find that tangent line at 2. So what do I need? I really need to know, what does g of 2 equal? And what does g prime of 2 equal? If I have that information, that allows me to go back and get the tangent line. Because remember, this is a two-way street. If I know the tangent line, I have the data. If I have the data, I can get the tangent line. So let's figure out what things would be. So let's plug in 2. G of 2, according to the rule, would be 2 times f of 2. Because I'm replacing everywhere I see an x, I'm putting in 2. I know what f of 2 is, so this is 2 times negative 1, or that tells me that g of 2 is negative 2. Well, that was pretty good. Nice and straightforward. Okay, how about g prime of 2? Well, if I want to find g prime of 2, a stepping stone to get there is to first find g prime of x. So what is g prime of x? What rule do we need to figure that out? I see I have a product of x and f of x. So I need to apply the product rule. So I'm going to take the derivative of the first, which is 1, times the second, f of x, plus the first, x, times the derivative of the second, which is f prime of x. So that's the general form for the derivative. Now, plug in 2. So g prime of 2 would be f of 2 plus 2 times f prime of 2. All right, well, that's good. Cool. Well, let's plug in what we know. We know what f of 2 is. It's up here. It's negative 1. So this is negative 1 plus 2 times f prime of 2, which is 3. So that's negative 1 plus 6, also known as 5. All right, good. So now we found what the function is at 2, what the derivative is at 2. We can put these pieces of information together. And what do we get? Well, what happens here is we're going to say that our tangent line is y minus our y coordinate, so y minus minus 2 is equal to our slope 5, x minus our x coordinate, which is at 2. So our y coordinate is the value of the function. The 2 is because we're doing everything at 2. 5 is our slope. So we can rewrite this. We get 5x, and this is minus 10, but then we're going to bring this across as minus 2 more. So 5x minus 12. And there you go. That's the answer. Good. Good. Woohoo! It's nice to be able to find answers. We like it when we find solutions. Okay. Well, let's try another one. All right. Given that y equals 51x minus 117. Okay. Okay, these are some really, really crazy numbers. Is tangent to y equals x squared g of x at x equals 3. Find the tangent line to y equals g of x at x equals 3. All right, kind of similar to the one we just did, but slightly turn it a little bit. So it's nice to be able to be flexible and say, okay, can I take what I just did and just turn it a little bit? So now, in this case, we have the tangent line to the x squared g of x. We want to find the tangent line to g of x. So what we're really after here is our sort of halfway goal, our sort of short-term goal, if you will, is we want to find what is g of 3 and what is g prime of 3. Okay. So what do we know? Well, what we know is that if I look at this expression here, this is our function, this is our tangent line. So let's think about what we can say. Well, at 3, we can say that the value of this line at 3, so we get 51 times 3 minus 117. Now, we have to think about what that means. 51 times 3 is 153. If you take 153, subtract 117, you get 36. So that's 36. That has to equal what happens when we plug 3 into here. So that's 3 squared g of 3. Or if you like, 9 times g of 3. Now, 36 is equal to 9 times g of 3. What does that tell us about g of 3? Divide by 9, and we get that g of 3 equals 4. Oh, a nice number. It's almost like they want us to have a nice expression, because of course they do. They like us. And what's not to like? We're very likable people. Okay, now, we're not done yet. We also need to find g prime of 3. Now, how do we do that? Well, we know that the derivative of this function has to equal what the slope of this line is, because the slope is storing the derivative, the rate of change. So, first off, I should say the derivative at 3. I misspoke. I forgot the at 3. Let's find the general derivative. So the derivative of x squared g of x. It would be the derivative of the first, which is 2x g of x plus x squared g prime of x. Now that's the general derivative. We care about what's happening at 3. So at 3, we get that 2 times 3 times g of 3 plus 3 squared times g prime of 3 has to equal 51. Slope of the line. Well, plug in what we know. We know what g of 3 is because we found it. So 2 times 3 times 4. Well, that's 6 times 4, which is 24, plus 9 times g prime of 3 has to equal 51. Move the 24 across, right? Yeah. 9 times g prime of 3 equals 27. Good. So we're getting there. We're almost there. What is g prime of 3? So g prime of 3 is equal to 27 over 9, which equals 3. Another nice number. You see, if we do problems well, and of course, if the instructors and problem writers are nice, we'll get nice values. Are we done? No. Are we close? Yes. Okay, how do we finish up? Well, we got to find a line. What we found is the information that helps us get the line. So to finish up, what is the line going to be? Well, now that we have this information, we can say y minus our y value is equal to our slope times x minus our x value, which is 3. So the slope is 3, x value is 3, y value is 4. Or we could say y is equal to 3x. Then we have minus 9, 3 minus 3, and then we're going to add 4, minus 9 plus 4. Minus 9 plus 4 is minus 5. 3x minus 5. And there we go. So yeah, the original values, 51 and 117, they were like, ah! But like 3 and 5, yeah, it seems pretty reasonable. Seems pretty reasonable. Good. Well, that's what you do. You work the problem. Work the problem. All right. This brings us to our last problem. Okay, let's see what it says. It's our last one, right? We've got to make sure it's a good one. Suppose that y equals f of x is a differentiable function, and that x equals 3, the line y equals 4x minus 12, is the tangent line to this expression, y equals f of x squared plus x times f of x minus 2x plus 2. And the question is, determine the possible tangent line, or maybe lines, to what y equals f of x at x equals 3. Now, I want to be careful here because I don't want you to get the idea, oh, is it possible to have many lines tangent at the same point? The answer is no. So what does it mean that there's maybe multiple lines? Because that's the suggestion here. And I'm going to say it again later. It means that we don't have enough information about f of x. We may not have enough to really nail it down exactly. And therefore, we have to be careful about any conclusions that are made. So we might say, well, we don't know what f of x is, but we can nail it down to several sets of possibilities. So that's what we have. All right. So let's think about what we can say. We need to start thinking about what's true. So we have this crazy expression here, very long expression, and we know a tangent line to that, which means we know values for that. So what do we know? Well, we're told that at x equals 3, this line is tangent to that point. So that means if I plug 3 into this line, I get the same thing as if I plug 3 into this expression. So we're told the following. Let's plug in a 3. So the fact that here we're going to do the tangent part. So 4 times 3 minus 12 is 0 equals f of 3 squared plus 3f of 3, then minus 2 times 3 is minus 6 plus 2. All right, good. Now, what is that? Well, we can actually play around with this. That's f of 3 squared plus 3f of 3 minus 6 plus 4. Yeah. Oh, whoops. That's minus 6 plus 2. Why did I write down plus 4? I think I was getting ahead of myself. I was trying to do too many computations in my head. Minus 6 plus 2 does involve a 4, but it's a minus 4. Okay, you don't want to get ahead of yourself. That's a dangerous place to be. Okay, now, what's going to happen here? Well, suppose this was all we had. Can we say anything at this point? If you think about it, you say, hey, it vaguely looks like a quadratic, right? Because I'm seeing squares. Whenever I see squares, I'm thinking quadratic. It looks like something like a y squared plus a 3y and a minus 4. Now, well, what does that say? Can I factor that? Well, can you? I hope so. Because almost everything does factor that we encounter. Not because most polynomials factor, but because we're trying to just get a good sense for how things work. So we want things to work out nicely. It does factor. I need two things that multiply together to give negative 4, which means we have opposite signs. So it's like y plus something, y minus something. So I need two things that add to 4, multiply to 4, but add to 3. Well, I should be careful here. Multiply to negative 4, add to 3. Do you see what does that? Well, how about 4 and negative 1? Because negative 4, right? Then you'll get a 4y and a minus y, which is 3y. Okay. So, what does that tell us? Well, it tells us that, hey, do you know what? We can say, we know that f of 3 plus 4 times f of 3 minus 1 is equal to 0. So at this state, without any additional information, there's two possibilities. Namely, f of 3 is negative 4, or f of 3 is 1. And I really want to emphasize the word or. When I say or here, I mean one of these two is true, but not both. Because one of the rules for functions is we always have to have a consistent answer. We can't be like, well, maybe it's both. No, it can't be both. You know, it's like ice cream. There's a chocolate, there's a vanilla, but there is no swirl in functions. There's no chocolate vanilla. That doesn't exist. Okay. All right. Back to the problem, Steve. All right. So we've now made some progress. We can know a little bit about what the function has to do. It has to do one of these two possibilities. Now here, when I said tangent, I'm using the fact that I'm touching the curve. Now I need to talk about the rate of change of the curve. So I know the slope of this curve. Since I know the slope, I can say something about the derivative. So let's start with what the derivative of this expression is. The derivative of f of x squared. Ooh, I don't think we've done that one. Let's do that really quickly. So the derivative of f of x squared is like the derivative of f of x times f of x. So what would that be? So take the derivative of the first, f prime of x, times the second, plus the first, times the derivative of the second. All right, that's what we'd get. And notice they're both the same. In f prime times f and f prime times f. It doesn't matter what order you multiply numbers in. It's always the same value. So this is really, I could write this as 2 times f of x times f prime of x. Interesting. I wonder if there's a nice rule here. I think if there was a rule that could help us do things like this, that rule could be an important change to what we're doing. Okay, all right. So back to the problem I had. Y prime, the derivative of f of x squared, that's 2 f of x times f prime of x, plus product rule. So then we're going to have derivative of the first, 1, times the second, f of x, plus x times f prime of x. And then derivative of minus 2x is minus 2. And the derivative of plus 2 is 0. It goes away. Now, we plug in what we know. We know at 3 that the value has to be the slope of the line, which is 4. So 4 is equal to 2 times f of 3 times f prime of 3 plus f of 3 plus 3f prime of 3 minus 2. Now, at this stage we say, well, hey, we have two possibilities for f of 3. So let's just sort of explore those two possibilities. So let's start with our first possibility. I like to start with 1. We'll have that be our first possibility. Because 1 is just so much easier to work with. So what do we get? If we plug in 1, we're going to get 4 is equal to 2 times 1 times f prime of 3 plus 1 plus 3f prime of 3 minus 2. Well, so we start putting things together. We're going to get 2 plus 3, which is 5. And here we have 1 minus 2, which is minus 1. In fact, we can move all of those to the other side. What we can get is we can say, hey, or we'll get 5 is equal to 5 f prime of 3, or f prime of 3 is 1. Okay, so if it's the case that f of 3 is 1, which it has to be one of these two things, then it's the case that f prime of 3 is also 1. Okay, so now we have that case explored. But it may not be the case. So we have to go down the other rabbit hole. Let's call this option 2. So recall that this one was option 1, and now we're into option 2. Let's see, I think there's a little bit of space down here. So 2, what do we get? Again, we're going to get 4 is equal to 2 times f of 3. So that's minus 8, so minus 8 times f prime of 3, plus f of 3, which is negative 4, plus 3f prime of 3 minus 2. Now, if we start moving things around, well, what do we have? We have a 4, there's a minus 4 and a minus 2, so that's minus 6. Move it to the other side, that makes it 10. Minus 8 plus 3 would be negative 5. So if 10 equals negative 5, f prime of 3, or divide both sides by negative 5, f prime of 3 is negative 2. Okay, so that's still a possibility. So f prime of 3 is negative 2. And therefore, at this stage, we've said, okay, what we've done is we've really said there are two outcomes that we've narrowed it down to. Namely, that one of these two pairs has to be the case. But it has to be one of those two pairs. There's no other options. So we can't get it down to a single line, but there's two lines. So one of these two is going to be the line, because there is only one tangent line. So let's talk about what the lines are. So here, the points are at x equals 3, y equals 1, slope is 1. So we would get y minus 1, that's where that 1 is coming from, is equal to 1 times x minus 3. And the 3 comes from the coordinate, this one comes from the slope. Or we get here, here's our y value, here's our slope. Y minus minus 4, so I'll say y plus 4 is equal to our slope, negative 2 times x minus 3. And negative 2, slope, 3 point. So those are the two possible lines that can work. And without more information, we can't narrow it down further. But I'd say we've narrowed it down pretty far. Wow, interesting. That's what an interesting problem. Of course, all problems are interesting. At least we hope. That's the goal. They help us learn. They help us get better. All right, so keep getting better. Keep practicing. And we'll see you some